Welcome to the next video of this section, using SQLite databases to handle a to-do list. In the previous video, we've learned how to use TList View to show and search local data. This video is about a to-do list. It is similar to the using TList View to show and search local data video, but in this case, we'll use a SQL database and we'll show data to the user using live bindings. Moreover, we'll see how to create output converters for live bindings. Usually, the mobile apps read or write data using the network. In many cases, however, you need local storage to save your data. A local database can be useful for a number of things. To buffer information while the internet connection is not available. To save information that will be realigned on the central server when back at the office. To store some structured data. To allow you a fast search on a relatively small set of data retrieved from the central databases and stored on the device. In all these cases, you have to handle a database. This video will show you how to do it. When you need a mobile database, you have two choices in Delphi: SQLite, an open-source embedded database, and Interbase to Go. Since version XE6, RAD Studio has included Interbase to Go and IB-Lite editions for embedded application development. You can deploy your mobile applications to iOS or Android devices with an Interbase to Go license at a cost, or IB-Lite license free. If your app is a bit more complex, needs encryption, stored procedures, or a number of data types, you definitely have to go for Interbase to Go. Otherwise, you can use SQLite. Consider that IB-Lite is the same engine as Interbase to Go, but limited to some extent. The biggest limit is lack of encryption. However, an app that uses IB-Lite doesn't require code updates if you need to scale to Interbase to Go. Change the license and you're okay. The video is very simple in terms of database requirements, so we'll use SQLite. However, the same concepts are applicable to Interbase to Go and IB-Lite. Open the todolist.dproj project. The main form has all the components that are required to access the database in a real-world app. Consider using a data module for this, just like the desktop applications. The app has been created using the header-footer mobile template. The first tab item contains the to-do lists, while the second tab item allows you to update an existing to-do list or create a new to-do list. When the application starts, the TFD connection components connect to the database. If the database file doesn't exist, the SQLite engine is configured to create a new database file from scratch. This feature is very useful and can be configured by setting the open mode parameter to create UTF-8, as you can see here. The UTF-8 encoding is almost always the best choice for international applications. In this case, it is the default setting for the TFD connection components. Here's the relevant part of the TFD connection parameters, and this is the database path on the Windows development machine. Another problem to solve is related to the database path. In Windows, you can develop your mobile app using the 32-bit Windows target and a local path on your system. However, when the app runs on the device, you have to use another path. How do we solve this? In the Connections Before Connect event handler, consider this code. With this code, the database will be created in the proper iOS or Android document folder, as you can see here. The next problem is related to the database structure. When and how do we create the table that we need? Let's check the After Connect event handler on the connection. Just after the database is created, and at any subsequent run, the app tries to create the database table if it doesn't yet exist. Then open the dataset connected to the bind source to show the data present. The list view is configured by adding the following properties. ItemAppearance.ItemAppearance should be list_item_write_detail ItemAppearance.ItemHeight to 100. Search visible should be true. The second tab contains a T-memo component, a T-switch component, and two T-label components. The T-bind source DB data source connected to the QRY to-do dataset is connected to the list and to the detailed component placed on the second tab item as well. This we will see here integrated with some clarifying text such as tab item and this is binding data source, and this is the tab item. All the code used to handle the dataset is normal dataset-oriented code, just like the code used to manage datasets on a desktop application. This project shows a nasty problem. SQLite doesn't have the Boolean field type, so the done field in the to-do table is a type integer, where 1 means true and 0 means false. However, we want to connect the done field to a tswitch.isChecked property of type Boolean. In this situation, when you try to change the switch value, you will get an error like this. How do we solve this? The live binding engine has a powerful mechanism to convert data from one type to another. When the result of an expression is of type X and the property where that value needs to be written is of type Y, the engine looks for a valid output converter that is able to convert type X to type Y. The available output converters are shown on the binding list 1.outputConverters property. As you can see yourself, there isn't an output converter from string to Boolean, which acts as we need. To solve our problem, we have to register another output converter object able to convert a Boolean value swtCompleted.isChecked to a string value because live binding uses the t field. Set text method to a set value of a field. This output converter is registered in the bool to string converter u.pas unit. The procedure used to register the new converter and makes it visible to the live binding engine is shown in this selected code. This unregister the default converter, which is from bool to string. This register the new converter, which is from bool to string. This converter is able to handle 1 equals true and 0 equals false. Now the app works properly. However, be careful now, all the conversions from Boolean to string will be considered true when 1 and false when 0. This internal mechanism of live bindings needs to be clearly understood because it can cause a lot of headaches in non-trivial cases. Full code of this output converter is available in the unit bool to string converter u.pas. Now let's run the code. On the second tab, there is a label that describes the meaning of the switch. When the switch is checked, the label says the task is completed. Otherwise, it says the task is not completed. This feature has been implemented using live binding expressions. Go to the Live Binding Designer and select the arrow that connects the Done field to the lblCompleted.text property. Now hit F11 to show the Object Inspector window and check the Custom Format property. Here, a logic has been used by the label. The expression is reported like this. This code is a relational expression that transforms a value read from a dataset field to a text value shown in a label. Normally, the value is read from the source component and written on the target property component. However, using the custom format property, you can change this default behavior to get more complex and useful information. This expression is a good example of that. As you can see, mobile development is a mix of well-known things and new things. The live bindings framework is a big new thing, and you can be frightened by it. However, don't be afraid. All your needs are there. Here is our to-do list app running perfectly. Here are some useful links to go deeper with the concepts exposed in this video. Another approach to the integer as Boolean problem can be found at this site. Information on formatting fields using live bindings can be found at this website. Documentation about output converters can be found at this link. Some tutorials on live bindings in RAD Studio can be found at this site. Cool! We've successfully learned how to use using SQLite databases to handle a to-do list. The next video is Do not block the main thread.